Hello. So time to start. This is the Bess session in Prague. Can I have someone to close the door, please? We have to start very now because we have a very packed agenda. Okay, let's start. The not well first, please read it if you are not aware about it. It globally says that whatever you are doing here, it's considered as a contribution to the IETF community. Blue sheets are circulating. Please ensure that they are coming back to our table at the end of the meeting, please. So, first of all, website updates. So we did some work. The first one is that we are now providing on the main page of the Bess working group some additional links. So there is a link to the implementation requirement policy, which was previously just an email in the archive. So now we have a pointer to this, which is quite clear. And we have the new wiki. So I hope people are enjoying the wiki, and I hope it will be useful for the working group. Milestones. One of the action items we had from the last meeting was to refresh the milestones. So we have set up a couple of milestones. So the first one is about the MVPN model, which is targeted to be sent to the IESG on June. So it is quite urgent to progress on this document. For the NSH control plane, based on the discussion with the authors, we set a milestone to send the document to IESG by March. We are a bit late on that. However, we are in Shepherd review, and there's just one additional thing to fix in the document, but it's really in the good way to go to IESG soon. Do you have one comment now?
Is there a switch on it?
You can come here if it doesn't work. Please run. Naim.
So for the L2VPN Yang model, we would like, the authors would like to make a last call for you to make a last call, because I think we have completed the work or addressed all the comments.
Yeah, there was an action item on this one and also on L3VPN and EVPN to make the model consistent. I don't know if this work has been done or not.
There are some outstanding on EVPN, but I think L2VPN part is done.
Yeah,
so,
but there was also some alignment to do with L3VPN.
That part is done as far as the interface or something like that, right?
That
I think there was
also kind of on the definition on the route targets, the route distinguisher, and so on. The modeling was quite different. I have sent bunches of comments after last IETF on that.
After last IETF?
Yeah.
Okay.
And maybe you have to check.
All right. Okay. But I think we want to just finish it off, get a last call. And
me too.
Okay.
But I want to ensure that all the VPN documents that we are producing are consistent in terms of modeling.
Okay. I think we have addressed it, but I will confirm. Okay.
Come on.
Yeah. I want to say with regards to EVP and Yang model, some of the BGP commands that are defined in the model probably needs to be merged in a way that it's consistent with BGP Yang model, which is not there. So I'll make a note of it.
Okay, thank you. So yeah, producing Yang models is something which is really important for the working group, and we need to progress fast on it. in order for them to be used by the operators. So we need to refine the milestones. I would like to get the documents to be sent to ISG by next ATF. Okay. And for VPLS multi-homing, I have to check where we are on this one. And for the EVPN OAM, it's still an old milestone, and we need to think about what could be a good milestone to this work. It's not done yet. Status update. So we have 3 new RFCs since last ATF, 2 about management information base. I think this will be the 2 last one, maybe for the whole ATF. And we have the explicit tracking also for MVPN, which is also an RFC now. We have still several documents in the RFC editor queue. Some of them are still waiting for another document to be RFC before moving forward. One of the important ones for us is the EVPN prefix advertisement, which was relying also on the internet subnet forwarding. But this document has just been pushed to Martin for AD review, so we are on the good track to close this work. And DF election, it's in RFC editor. This is also an important piece of work. So Martin, I think you have now 2 documents in your bucket: the optimized IR and the new inter-subnet forwarding. Still not working?
No, I've asked.
Okay. Okay.
Sorry, I wasn't listening to Himanshu when he said it wasn't working. So yeah, I have 2, and I think I've pinged the authors of some documents on which those depend, because I don't want downward ref. If you don't know what it is, go and read some RFC. No, I'm waiting a bit to be able to process several documents which have dependencies amongst them as one batch. But as I understand from discussing with the authors and the chairs, they should be ready soon, and so we won't have to wait much longer.
Thank you. We don't have any document really ready yet to go to ISG. However, we have several that are under Shepherd review. There is a virtual Ethernet segment one. I think, Luc-André, you provided a review on it. Did you receive any comments? Ali? Okay. Someone is coming to try to fix it, otherwise you need to come here. We have no choice. Yeah. I think VPLS multi-homing, do you have the status on this one? It was one of you? Yeah.
So that one we're still waiting for an update.
Okay.
The editor on that one has gone very quiet. On VPLS multi-homing, so he hasn't been responding to my emails. Okay. So if you're one of the other authors, if somebody else wants to take up the pen on that again, that would be great.
Okay, next one is the Bess service chaining. For this one, we have a major issue because the document is far from being ready to be sent to ISG because it's targeted to be standard track. However, there is pretty nothing standard in terms of normative language in this document. So the work is quite huge to make it really standard track, at least the way it is described today. So one possibility that the authors are offering is that they propose to split the document. One for the BGP extension, which will be standard track, and the other one to be informational. And this may ease the possibility for the document to progress, because making it standard track the way it is presented today, that will be a huge work, I think. But it's also depending on the interest of the working group to progress this document. The authors would like to progress it, but we also would like to hear the feedback from the working group. So who in the room would like to see this best service chaining document to be published as an RFC? No one? Who absolutely do not want this document to be published as an RFC? Okay, so nobody cares.
Okay, just another update on the VPLS multi-homing. I did actually receive an email from the editor about a day ago. So they're just waiting for the IETF submission process to reopen, and then they'll submit a new version. We've been waiting for a few months, I think, for that. I think after that's done, then we can proceed.
So to finish about this best service sharing document, we will take it to the list to see the interest of the working group to progress it, because if only the authors would like to progress it, maybe we will stop there. BUM procedure updates. We are just looking for a shepherd for this document. So if there is any volunteer to provide a review and do the follow-up, yeah, that would be great to help us. NSH BGP control plane, as I have said before, it's almost ready to go. Just have an update to do, and then we'll be good. MVPN fast failover. The document has failed. The new working group last call and new questions has been raised by Jeffrey. So I don't know if Greg is there. Do we have Greg Mirsky in the room? No. So yeah, Greg has to provide some feedback to Jeffrey on this one. We have a lot of documents that are pretty ready for working group last call. If our queue is not up to date, and if you think, for example, that one of these documents is not ready for working group last call, please advise us to make it updated. The thing is that at a certain point, we have a bottleneck. If we have too much document under Shepherd review, and if we don't have enough Shepherd to review the documents, we may not be able to accept any additional working group last call. So you need also to help us to review the documents to make the process going faster. So if you want to review any documents, feel free to be volunteer as a Shepherd. We have 4 new working group documents. I may say 5 because I think today we have a new working group documents because we have an adoption call that has ended today, and we have significant support, so I think the document will be adopted. We have also bunches of documents that could be ready for working group last call. Again, if our queue is not up to date, yeah, just let us know. And yes, we had this ongoing poll about the IRB extended mobility. So the poll was extended because of quite a lack of support, but now we have significant support to make it adopted. Working group status, so I will not review it, just for information. This is the feedback that we have received from the different editors of the working group documents. However, we are still missing a lot of updates on some working group documents, so please ensure that we get an update before the meeting, but also in between the meetings, so we can track the different issues we could have, and we can also help you in case if it's necessary. So it's just for information. Yeah, so as I just said, we are expecting updates not just before the meetings, but also in between. So the next update to be provided should be around mid of May. Okay, so for sure, Mankamana will push you to give the update, but feel free also to just send the update when you are ready. Okay. About the action items from the last ITF meeting, so the milestone refresh, so this was an action item on our side and it was done, and we now need to keep it updated. The inter-subnet forwarding draft, the action item is done also. The consolidation of the Yang models, so I understand that maybe there is still something to work on this part. And there was also an action item on an errata that has been published and then refused and has to be republished. But I think, Ali, you are proposing something on this too. So Mankamana told me that there is a Bess version that is under preparation. Do you want to talk about it?
It's very simple. I mean,
on the mic, please.
Working?
Yeah, it should work now.
Yeah.
State your name first.
Ali Sejansi. So the errata are very simple, the one that being compiled, and that can be done in 10 minutes. But there are certain sections that needs to be improved and certain sections to be clarified. And one other section needs to be added. And so I want to do, all these in the these new 7432 Bess. And so it's going to, the scope of the work is bigger than just initial errata.
Yes, that's true. I'm just wondering, do you think it's the right time to start the Bess version, or do we need to wait for more experience on EVPN deployments before raising it?
I think over the past, the deployment has started like 5 years ago. So over the past 5 years, we've gathered input and comments with respect to what areas are not clear and needs to get clarified and so forth. So I think we got the data points to move forward. So it is the right time.
Okay, so anyway, we can start the work. And
sure, we're going to start the work after the ITF, but I don't want to push it to say that it's going to be finished before the next ITF.
That's definitely not the goal.
Okay, all right. Sounds good, thanks.
Okay, agenda, really packed, really full. We are a bit worried about this agenda. The first thing is that there is just one working group document update in this agenda and plenty of new working group, new individual documents presented. We would like to get also presentation on updates of working group documents because this is our priority in terms of work, of processing work, and we need to progress the working group documents. At a certain point, honestly, I don't think we will be able to adopt any new working group, any new document as a working group item if we are not able to close the existing working group documents. Okay? So it's been now maybe 2 or 3 or maybe 4 ITF where we have almost full session. For the next one, maybe we will ask for 2 slots. 1 slot may be dedicated to update the working group documents, and the second one to provide additional work as individual, for individual documents. But we absolutely want some updates on the working group document. Any comment on our working group status? Okay, so let's start. Patrice, you are the first one. Oh, Luc André. Okay.
Hello, my name is Luc André. I'll be presenting today updates to 3 drafts, one working group document and the other one personal drafts. So the first one is the EVPN Yang model. As you heard, essentially the EVPN Yang milestone was missed, and we're now trying to close this working group document. So a couple updates since the last IETF. The first one is the Ethernet segment definition in the Yang model was very incorrect. So what we did was update that to actually define an Ethernet segment identifier type and replace this throughout the document to more accurately represent the 10-octet ESI value, as well as some cleanup for places where routes actually had no Ethernet segments. The second thing that we changed was normalize some portions of the Yang model to standard Yang types. So two major things actually. The first one is normalized MAC addresses from hex strings to the Yang MAC address type from 6991. The second one is to normalize the BGP route targets to 8294, which is the routing area base Yang types. A third thing is that now the Yang validator tool is available and is actually mandatory for Yang drafts when you update them. So as this draft was reposted and updated, actually there were a couple red flags that came up from Yang validator. So these were fixed in the draft, just minor versioning and syntax corrections. So the next steps, actually there are, so I list 2 here, but there are 2 or 3 next steps. The first one is there's still 1 or 2 feedback on the alias that need to be addressed. And the other one is actually the comment that Kayur made is the BGP portion of the draft, and I got this comment several times actually. The BGP portions should be folded into essentially the BGP base with essentially just define only the extensions to that for EVPN. So essentially I was going to seek last call, but I think the idea here would be to publish an 08 with everything that we collect this week, and that would be on the alias rather than here today. So that's it for this one. I don't mind doing this in line actually before I skip to the next update.
Cool. So real quick comment, K. Patel Arcus. The BGP Yang model is going to be discussed at the IDR working group. We will work closely with you and make sure that this is taken care of in the framework of the BGP model.
So the second draft I'm presenting is the EVPN L2 Gateway Protocols draft. So this draft was updated to reflect some comments that were received on the alias. Namely, the first change was to add a section describing what I'm referring to as the 2ESI solution. This is essentially provided more as a background or an option. I guess I shouldn't say option rejected, but an option which is which this draft builds upon with the one ESI solution. So the 2ESI solution achieves some, but not all of the requirements that we're trying to address with this draft. However, it has the benefit of being 100% backwards compatible. So a new subsection on this backward analysis was added to version 04. Secondly, a section was added on convergence. So just a broad description of the applicability and operation of, for example, the backup path from 7432 and how it applies to this, this new load balancing mode. Third, based on a comment from Jorge, we adopted the MAC flush extended community rather than define a new one. So this extended community is borrowed from RFC 7623 from the PBB EVPN draft. And that extended community is borrowed to be applied here on the EVI EAD route, which is where the MAC mobility extended community we were defining was previously. Next, there was a section on EVP and IRB in this draft that was added, essentially the applicability of EVP and IRB and how and the procedures to achieve EVP and IRB with this load balancing mode. So the next steps, essentially the logical next steps for this draft would be to bring it to the working group.
Just one question. Who has read this document? Raise your hand. Okay, thank you.
Just one quick question. Yeah, Jorge Rabadan, Nokia. So the backwards compatibility section is a bit misleading. So are you claiming that the one ESI solution is backwards compatible or not? To me, it isn't, but the section is actually confusing.
Okay, so I can go over it again. The claim is not that the one ESI with the new flag would be backwards compatible at 100%. It is backwards compatible if the receiver of the route ignores any bit other than the two existing bits. So it's a third bit being defined, and only when that one is understood can the others be ignored.
Even if it is ignored, for the remote PE means that it's basically all active because the single active bit is not set, which means that a remote node will do aliasing and it wouldn't work.
That's correct. And the idea for that is it may work in some scenarios. For example, EVP and IRB, we would have suboptimal routing. So the load balancing mode would set up suboptimal routing. But I agree, if I can go over this section again and be absolutely categorically clear.
Okay, thanks.
The third draft, the last draft I'm presenting, is version 3 of the port active draft. So the first thing that was done is essentially a cleanup based on comments, either on the alias or in person, I forget, regarding the use of non-standard terminology in the draft. And then there was a few references that needed to be updated. So just a bit of housekeeping there. This section for port active over IRB interfaces, so port active into EVP and IRB, we found that it was actually not as clear as it could be and somewhat superfluous. So that section was actually removed in order to move the document forward. And in the sense that can essentially be addressed either later or differently. It doesn't have to be addressed in this draft. And the next point shouldn't be indented like that. So the draft was updated to include a recommendation to use RFC 8214, so the EVP and VPWS L2 attributes extended community, when port active is the load balancing mode into EVP and VPWS. So the next steps for this draft is actually something that we forgot for the 03 version. So it would be to define either a DF election type or a DF capability flag in the DF extended community from the DF draft. So either request an IANA port active algorithm or a capability, and then essentially move the draft forward. Jorge
Rabadan, Nokia. My suggestion would be to ask for a capability because you can actually use it with other DF election algorithms, not only HRW, or you can use it with preference based on or any other, right?
Yeah, so my personal, I was personally leaning towards capability because as the draft stands today, it actually defines both modulo and HRW. So in order to keep those DF modes, it would have to be a capability with those modes. Sure. So that was I was personally leaning towards that, but obviously I left it open.
Yeah, you could also use it with preference based.
For example, also.
Yeah. Any others in the future.
Thank you. Thank you.
All right. Alice Agency, Cisco Systems. So this is a draft that I presented in the last IETF, and it is, even though the name says secure EVPN, the document talks about the applicability to other VPN types, L3 VPN, MVPN, VPLS, and so forth. In this draft, we have some modifications that I'm going to go over it for this revision. Before doing that, let me talk a little bit about the solution overview. This secure EVPN is not about the bootstrapping the IKE v2, because some people are confused that, okay, there is a RFC for that, 5566. This is not about that. This is about, instead of using the IKE v2 to set up the IPsec assays, we use the BGP point-to-multipoint signaling to do that. And in IKE v2, we have two stages. First, authentication of the peers, and then after that, the encryption of the traffic channel. And in here, we are saying that the authentication piece between the peers and the controller, we can either use existing point-to-point IKE v2, or we can use TLS to do that. And so we send the BGP is going to go over that secure channel. And once we have that, then to set up the point-to-point IPsec tunnel between the peers, between the routers, we use the BGP signaling to do that. And the advantage of it was for the scale, instead of having ON square signaling session, it's going to reduce to ON for the for BGP. So when a PE first comes up and wants to set up an IPsec assay between yourself and each of the interested remote PEs, it generates a DH pair for each of his intended IPsec assays, and that based on the IKE v2 Diffie-Hellman group transform IDs. And the originating PE distributes DH public value along with the nuance and some other parameters via the ROS reflector to the others. And the receiving PE, when it receives the public value, it can establish the IPsec assay pairs to the originating PEs. We talked about the two types of encapsulation, which I'm not going to go over it. So the changes to this rev, there were some editorial, and the Rev 0 draft talks about different level of granularity that you can set up the IPsec between two PEs and aggregate all the traffics over that IPsec tunnels at the peer level. We call it peer level, and you can have one or more multiple such tunnel per peer. So that's at the peer level. Then the next level up is at the tenant level, and then the next level up after that is at the subnet level, and then you go on, and it is at the VPN IP address or VPN MAC address level. So we have this level of hierarchy, and we added one more in case I need to set up an IPsec session between the two attachment circuits. So that got added, and we also added a new section on inheritance, because there was some confusion regarding that, and I'll go over it in a minute. And also we modified the sub-TLVs for better optimization, which I'll go over it shortly. In terms of the inheritance of security policy, the question was, okay, if you have these different levels, then if I want to set up the IPsec tunnels, let's say at the tenant level, for some VLANs, but not for some other VLANs, how does that work? And the idea is if you don't specify these IPsec attribute when you advertise it with the tenant route or subnet route, if it doesn't have this attribute, it inherits the attribute of its parent, and the parent can be a peer. So you set up the IPsec tunnel for a peer between PE1 and PE2, and then for the tenant, if the tenant has explicit attribute for the IPsec session, it uses that. If it doesn't have it, it uses the parent one. So we added this new section to clarify it, and I think there is still room for improvement. After some discussion, we think still, there is a room for improvement of that section. And the other, these are the different level of granularity which I went over last time. And with the TLV, for these IPsec, we have a minimum set, and then you add to that. The minimum set that is needed to set up the IPsec is the ID. You need the identifier. You need the notification bit to indicate this is whether it is for the first time you're setting up this IP tunnel, and then along with the rekey counter, you need the key exchange and nuance, key exchange data and nuance. The ID rekey counter along with the bit and the nuance, these three, we packed it into a TLV called base TLV, which is this one. And the format of this, you will see it is different from what we defined before. And then after that, we can send along with that the other sub TLV to indicate the key exchange data or policy, which is, we call it SA proposal sub TLV. For the minimum set, we need to send this TLV along with one of these, only one of these. That's the minimum set. And however, you can, if you want to support multiple policy, you can send multiple of these key exchange and multiple of these SA proposal. So if you go over this TLV and compare it to the previous rev, you can see it is better, the previous rev was just purely based on the IKE definition, whereas we've optimized it for our purpose in here. So that's a wrap for this version of the draft. And we want to solicit more input, publish the Rev 2, and then after Rev 2, we're going to request for the working group adoption. Go ahead.
Keyur Patel, Arcus. There are 3 different proposals going on between IDR group and Bess, so note to a working group chair. Please make sure you coordinate this, because they all run on top of my draft, which is tunnel and cap in some form. They need to be coordinated. The second comment I have is you can...
On top of what draft?
Tunnel and caps.
Tunnel caps.
Well, this is based on the tunnel and cap.
That's precisely why the note to the chairs, not
right.
to the authors.
Whereas the other 2s, they're not. But one of the other 2 is for a different functionality. Anyway, go ahead.
The second comment I have is you're exchanging keys.
Pardon me?
You're exchanging keys here.
Yes, exchanging, yes.
You're exchanging that over unreliable transport.
It is not under reliable transport. We are sending it over BGP, and the BGP itself gets sent over the encrypted tunnel.
Okay, so the tunnel's been established and you're sending keys over?
Yes. Okay. What that is point for between the PEs and the controller, those are the point-to-point tunnel. It can be TLS tunnel or it can be IQ2. Okay. You establish those first. Okay. And then once you have that, for the setting up the peer-to-peer between the PE to PE, That part of it, you don't set up the, IPv2 session. You use the BGP that is already goes over the secure tunnel.
All right, I just wanted to make sure because the sub TLV mentioned, and then I have few more comments that I will send it out to you. But is there a way you protect this from going across the AS?
To protect it to going across the AS?
Yes.
Well, this is the...
Do you have procedures to make sure it doesn't get leaked inter-AS?
That is not currently in the draft, but we can look into that. Thanks. Yeah.
Before the next speaker, I would like to come back to the comment from Keyur about the differences or the discussion you could have had with other authors, like Linda or Ron and Eric, about their L3 VPN, secure L3 VPN and SD1 stuff.
Right.
What's your position?
So we had
because what we need in terms of working group is to build reusable building blocks.
So we had some discussions between the authors of the two offline, and we thought we concluded that we're going to have a one solution draft, which is this one, and to have one use case draft. And then in the use case, just like we have a use case draft for the EVPN that talks about how the EVPN routes are used for different use cases. We decided it's a good idea to be able to do that in here. However, it seems like there is some misunderstanding because I was a bit surprised to see in the IDR the other draft got presented. So we're going to sync up tomorrow, trying to resolve that.
Yeah, so in your view, that should be the building block document, and then there could be additional use case document, whatever.
This is correct. This is a solution document, and then there is then we can have a use case document to describe how these routes are used for each use case.
Okay, thank you. Linda, is that the same comments that you have discussed during IDEA?
Oh, okay.
Because actually, we are very, very tight in terms of time.
I want to bring up a different issues here. Just before this, we had the iTunes SF discussion. We had spent actually quite a few months on the IPsec configuration from the controller. So my suggestion is we should have one place to discuss all the controller dictated IPsec configuration, then putting into either BGP or data model, NetCom data model. So we should have consistent, because the way you have it today here, the IPsec, miss quite a few things. You have one type of implementation, IPsec binding with the client traffic, right? There could be other implementation. The IPsec is bounded with the external ports. And then you have a child traffic selector selecting the traffic to be associated with each of them. So those are the two different type of implementation.
Okay, so I understand that there are still some discussions that need to happen.
Yeah, and also the IPsec.
No, I'm sorry, but we are a bit out of time, so you have to let the room for Lou to get his comments.
Okay, so just one.
No, we are out of time. Sorry.
Okay.
Lou Berger, thanks.
Very fast, Lou.
Okay. All the IPsec pieces that you're doing, or sorry, King pieces that you're doing, are they going into this the sub TLVs?
Sub TLVs, correct.
Yeah. Okay. So did you look at what we did in 5566?
I did.
Yeah.
I did this afternoon.
Oh, good. So you'll see we had just the authenticator. Part of that was because there was a lot of pushback. We had a lot of tension.
Right.
With the security area. Have you talked to them about trying to enable key exchange?
I can tell you I have seen the tension.
Yeah. So just be aware that what's in 5566 was took a long time and a lot
to get it to that point. Yeah.
To get even that little point there.
Right.
Because we started out saying we were going to do basically what you're doing here.
Right.
And then we said, fine, we're going to do nothing, and then we ended up in this middle ground. So I would suggest if you're going this way, really engage with them.
Right. There are some discussions on that, and there is a parent draft to this, which it was presented in the security working group, and some discussions is going on that. So.
Yeah, one of the things we got huge pushback was trying to do anything that looked like key exchange over BGP, because it just was said that we can't trust that as a secure channel.
Okay.
Even and we talked about exactly the point that you made of, yeah, we can run over secure tunnels, and like, no, you can't.
So I guess we need a little bit more discussions on that with the security.
Please take it to the list.
But that's a good point.
It's the security area. It's
not
the routing. It's not this area or this working group that's going to have problems.
We have to stop now.
Martin, just an ESG perspective. Please seriously consider the comments you have received.
I'm sorry, I couldn't quite hear it.
Please seriously consider the comment you have received. Otherwise, your draft could spend a long time in ESG.
Especially with the security group, with respect to security group.
Okay. So next speaker, Jeffrey. Jeffrey, can you do it in 20 minutes instead of 25?
Okay, so a very quick update on the BGP signal multicast. There are two drafts about this. The first one is BGP multicast. It's still the traditional multicast like a PIM or MLDP. And the only difference is that instead of PIM messaging or MLDP label mapping, we're doing it in BGP. Everything else is the same. There are advantages of doing this signaling in BGP. I'm not going to repeat those here. This was the updates. The difference in the 0.2 version is that the signaling we now use a different CEFI. Previously, we used the C MCAS CEFI defined in that working group document ITU Bess MVP in PEC drafts. The authors actually have decided to stop working on that one. Everything will converge into this new BGP multicast, because this is like a generic one that works in all the situations, and the other one is just PEC interface. So that's the update. The next one is controller-based signaling. The difference from this one, controller-based, from the other one is that now the signaling is from the controller. The controller knows everything, the topology, root leaves, and then calculates the tree, figure out exactly how the forwarding should be done in each node on that tree. And it goes to that node directly and program the forwarding state there. That signaling, so difference one from basic, to summarize, is from whether it's leaf initiated or controller initiated. We continue to see comments that the authors believe that the documents are mature and stable and ready for requesting the working group adoption. We also have two new authors join the multicast signaling draft. There are actually customer interest in both methods, so we want to go forward with that.
Okay, who has read the document? Okay, a few. One more touchy question. Do we have some operators in this room interested by such design, by using BGP to program the multicast? Do you want to tell some words, Jim? Or do you want to say something? But you have an interest in it. Okay.
Thanks. The next presentation is about 3 related drafts, and I'll get to what happens eventually. Some backgrounds, especially this PIMZ term they used in MVPN. It's provider multicast service interface. It's a virtual interface used to sending or receiving customer multicast traffic through the provider network. It's instantiated with provider tunnels and advertised in the inclusive or selective PIMZ AD routes. In that route, you could attach a tunnel attribute we call PTA. That there you specify the tunnel type and tunnel ID. In the eVPN case, the eVPN IMAD route is the equivalent of the IPNG AD route. And then the tunnel segmentation. Let's say you have a network consists of multiple ASs or areas or regions, and for whatever reason, technical or administrative reason, you have to use different tunnel types or tunnel different instances. Then you use this procedure called segmentation points. The segmentation points re-advertise those PNG routes from the upstream region to downstream region, and it changes the PTA to specify the tunnel type used in the next region. So the forwarding at the segmentation points, it has been assumed to be label switching. Traffic arriving from an upstream segment on that segmentation point is label switched to the next one. And it's just like a unicast inter-AS option B. To do that, we require the per PNG label. And in case of the P2MP or beer tunnel, that requires the PNG AD routes to advertise those per PNG label. Now, there is another situation where when you use RCVT, P2MP, or high ingress replication or beer, the ingress PE needs to track the egress PEs. They need to receive traffic so they can forward the traffic selectively. To do that, there is this procedure called explicit leaf tracking, and that uses leaf AD routes. In case of eVPN, SMAD routes are equivalent of leaf AD routes. So in the MEPN case, the SPNG AD route would have a leaf information required bit set in the PTA that triggers the egress P to send leaf AD routes. Now, to reduce the number of the SPNG routes that is used for tracking purpose and then there is an enhancement where you can set that per flow leaf information required flag in that star G or star wildcard SPNG routes, so that for more specific SG flows, the egress Ps will send leaf AD routes back without corresponding more specific SPNG AD routes. That makes it leaf tracking easier without corresponding individual SPNG route. But that caused a problem with segmentation, because now without those corresponding SPNG routes, you can no longer advertise corresponding labels that is required to do label switching. So now getting to this draft share, originally in the beer working group, that draft was brought up because beer ABPMs explicitly disallows the per flow tracking with segmentation because of the problem we just talked about. Therefore, that draft share was proposed to say that in that case, let's use IP forwarding at the segmentation points. That way, you can still do the LR per flow tracking without the corresponding SPNG routes. But that generated a lot of discussions. The most important one is that IP forwarding at segmentation points is much more heavy weighted compared to label switching. So some operators would rather do label swapping, label switching. And in that case, you could actually trigger SPNG routes from the leaf AD routes. Just reverse it. That solves the label switching problem. There is a counter argument for that is now you have more control states for the because now you're defeating the purpose of the LIR per flow bit. But then there is a counter argument for that is that yes, you have the more control plane state, but your forwarding state is much less than IP forwarding. And Another counter argument for that is that when you do that, you will introduce a delay in the setup of your label switching state, and then it causes the traffic loss when you do the switching. Now, there is also a counter argument for that and the mitigation. So lots of discussion there, and also this is not specific to beer or MVPN. So draft John, Bess MVPN, EVPN draft was brought up to first explain the problem that is not beer specific, that applies to both MVP and EVPN, explain why the label switching has been the sort of de facto forwarding option. And then it also documented the IP forwarding method if you really want to use it. But we point out the pros and cons of both methods. And also we're trying to lay out the basic rules that can allow you to do label switching when you want to, even when you want to do IP forwarding. So all those rules I will not get into. And finally, that original beer specific draft was rehomed to the Bess working group, not adopted yet. So that's the third draft listed here. On the other hand, we finally, among the authors, we have agreed that all this work will consolidate to the draft John. So next step is that we polish the draft John. We'll likely take the beer specific text from the draft share, and then we polish it and seek comments. And eventually when everything is ready, then we, yeah.
A couple of clarification questions, Alice Johnson. So the assumption in here, as you mentioned earlier, is you do label switching. So the service layer is MPLS. How about the situation that I am doing, one area is doing MPLS, the other area is doing VXLAN. That requires the IP forwarding at the switching point, right?
That's true. We are not considering that, but we could add that into the consideration.
I think it would be good to add it. And then the question is, does it make sense as a common denominator to use the IP forwarding, because IP forwarding works for all scenarios and it makes the control plane simple. And then the counter argument with the IP forwarding that you mentioned, it is heavy. That is platform dependent. For some platform it's heavy, for some others they're not. So
right. That's why we're documenting both options, and we list the pros and cons of both options. Yes.
I agree. But the question which I have is, does it make sense to use to have the IP forwarding as default, because it's the simplest?
That's we can discuss further, but I think it's up to the. It's probably not good to have this default option, but we lay out the options for the operators to choose, because different operators may have different opinions for different scenarios. So we just document the options and do whatever they choose.
Okay. Yeah. So there is no default option in the draft?
No.
Okay.
Yeah.
Thank you.
So this one is about some clarifications or edit procedures for MVP inter-AS multi-homing situation. First of all, this draft, the earlier versions cover quite a few scenarios with clarification enhancements. I'll skip those. I will talk about the new scenario that this update covers. Look at this diagram here. We have 4 ASs. Source AS 100 at the top, the transit AS 200, and then 2 egress AS 300 and 400 at the bottom. We're using inter-AS segmentation, and we're doing per AS aggregation, which means that the ASBRs will advertise inter-AS IP0 route, which is type 2 in MAPN case. The source is multi-homed to P1 and P2 in the same AS. And now, if you look at the P3 at the bottom in AS300 and P4 in the AS400, they do their upstream PE selection. Potentially, they could choose different upstream PEs. For example, PE3 chooses PE1 as the upstream router, and PE4 chooses PE2 as upstream router. Because of that, when PE3 and PE4 construct their C-multicast join routes, C-multicast route, basically it's like a equivalent of pin joints, they will use this, construct the same RLNI, basically same route key, but with different route targets. One targeted at PE1, the other one targeted at PE2. When ASPR 22 receives that at the bottom from the two egress PEs, it's going to pick one of the routes and propagate it towards the source CS. So eventually, only one of the two PEs, P1 or P2, will send traffic. The other one will not send the traffic. Now, the first problem with that is that if you're using selective tunnels, then PE3 and PE4 only joins the tunnel rooted at its chosen upstream PE. So let's say PE3 will join PE1's tunnel and PE4 will join PE2's tunnel. Now, only PE1 is sending, then PE4 will not get traffic. So that is one problem. There is a solution for that. In fact, the procedures specified in version 0 about C-multicast route propagation rules actually allows you to construct the C-multicast route based on the ingress PE instead of based on the ingress ASPR. With that, PE3 and PE4 will construct different routes. So now P1 and P2 will both get the C-multicast routes, and then both will send traffic. And when you use selective tunnel, each will just receive the traffic from their corresponding upstream PE on the corresponding tunnel, no problem. The second problem is that after your problem 1 is solved, but if you're using inclusive inter-AS tunnel, now when both PE1 and PE2 are sending, and then the same ASBR will inject the traffic into the same inter-AS tunnel. Now P3 and P4 will get 2 copies for each packet, and it does not know which copy is from which router. So they cannot do the discard the traffic accordingly. The other problem is that, well, actually, that first problem 2A can be solved if you when you do the upstream PE selection, you always use a single forward selection. Basically, I don't care how close it is. I will just all the routers will pick the same PE if the source is in a different AS. Now you will only send one copy. But the second problem is that okay, I got myself confused. The first problem is that when you both are sending, you will send two copies across your inter-AS links, and that is not efficient use of the inter-AS resources. But single forwarding selection I mentioned earlier will solve that problem. That's still the selective tunnel case. I got it wrong earlier, but then in the inclusive tunnel case, that's where you have the traffic duplicate problem. That's the problem 2B, and there are 2 options to solve that problem. The one is that the ingress ASBR will attach a label to the traffic when they inject the traffic into the inter-AS tunnel. That way, the egress PE can tell which copy is from which ingress PE. The second option is that ingress ASBR actually does the IP forwarding. That comes back to that earlier topic that in some cases IP forwarding is desired. So in this case, the ingress ASBR will do IP forwarding, and it will choose on behalf of others ingress P, and it will only accept traffic from its own choice of orchestration P and inject the traffic into the tunnel, and everyone is happy. So I quickly went through this. It's a lot of details there. If you could read the document, talk to us on the email, on the mailing list. We want your comments. So then this draft, the documents covers quite a few scenarios. This new one is new, but other than that, the authors believe that the document is ready from the author's point of view. We want to request adoption because it solves real problems in the NVP and some EVP use cases.
Any question? Who has read this document? Okay, few people. Thank you.
Hi. Good afternoon. My name is Neeraj Malhotra, Arcus. Okay, so let's jump into it. Sorry. Okay, so the main sort of motivation for this proposal is the EVP and IRB network, or a layer 2 overlay network that uses EVPN as the control plane. So as it stands today, for an EVP and IRB or a layer 2 overlay network using EVPN, we don't really have a dedicated PEC control plane. So as a result of that, all CE MAC learning is based on data plane source MAC learning, and any host IP learning is based on ARP or ND snooping. As a result of that, what happens is with respect to CE MAC learning, the CE MAC learning is very, very tightly coupled with how often the CE is sending data traffic at any point in time. For example, following any convergence triggers or following a host mobility event, learning of that CE MAC is tightly coupled to when that CE will send the first packet. And with respect to the IP learning, it is also in a lot of scenarios very tightly coupled with CE behavior with respect to sending unsolicited ARP and ND packets. And on top of that, when we bring EVP and multi-homing, all active multi-homing into the picture, this data plane based MAC and IP learning is also subject to or has to deal with non-deterministic hashing of packets across the multi-homed lag link. And in addition, for a use case where the CE might have prefixes behind it, but does not run a dedicated PEC dynamic routing protocol on the PEC link, advertising these prefixes behind a CE is typically done using local policy configuration on the PE. So what is proposed in the draft is an optional PEC control plane that intends to fully decouple any CE MAC and IP learning from non-deterministic CE behavior with respect to data traffic coming from the CE, as well as non-deterministic behavior with respect to sending gratuitous ARPs or unsolicited ARP or ND packets. So in addition to, the eventual sort of goal being by doing that is to achieve a very consistent and reliable convergence behavior across all convergence scenarios and host mobility events. And in addition, while we do that, we also achieve a fair bit of or significant simplification in a lot of multi-homing related and workload mobility handling scenarios. So just a quick overview. The control plane proposed is based on link state over Ethernet as the base protocol. That protocol, it's a fairly simple link layer auto discovery protocol that is covered in a separate draft. In addition to that, so what this draft focuses on is basically it defines procedures and TLVs for MAC learning using this control plane. It defines procedures and TLVs for IPv4 and IPv6 host IP learning. And it defines overlay TLVs for IPv4 and IPv6 prefix learning via this control plane. Then, in addition, the draft also discusses essentially how to do all of this learning when the CE is multi-homed using all-active multi-homing. Then the draft basically goes into detail, discusses in detail several use cases that can benefit from this control plane. So the control plane itself is, I mean, it's fairly straightforward. LSOE that is used as the base protocol, it's a connection-oriented link layer protocol. So using LSOE, a connection or a session, LSOE session is established between the PE and the CE on the PE attachment circuit. Once the session is established, which is essentially using LSOE hello and open packets, overlay host TLVs are exchanged, which can include MAC IP TLVs and overlay prefix TLVs. And once the TLVs are exchanged and learned, LSOE essentially sends keep alives for session liveliness. Now, when we have multi-homing in the picture, when the CE is multi-homed using all active multi-homing links, a separate LSOE session is established to each PE. And this is a significant sort of part of the draft because now with a separate session to each PE has the ability to learn all the overlay MACs and IPs and prefixes independently, independent from the other PE. And as a result of that, basically, because you have this independent channel between the CE and each PE, all the MAC, ARP, and ND tables are automatically synced between the two PEs. So essentially, I mean, as it stands today, when because of non-deterministic hashing of packets, MAC and MAC IP packets, or ARP and ND packets on the multi-homed links, the PEs have to implement significant procedures to basically keep the tables in sync across the two PEs, as well as handle unsolicited ARP and ND responses. As an example, I mean, when PE2 ARPs for CE1, the ARP response could go to PE1, and the PE1 has to handle that unsolicited response and then sync the entry over to the other PE.
Yeah, you have to go to the conclusion. You are out of time.
Okay, all right. So just 2 minutes.
One.
Okay, 1 minute. Okay, so I'll just cover the mobility part. So basically, mobility is another really key use case for this. So if we look at like how mobility works today, right? Like so, the mobility detection is entirely dependent on receiving a data packet from the CE after the CE has moved. And once you receive the data packet from a CE, typically that MAC move event is punted to the CPU where the software reacts to it, and the software may not yet have learned the MAC IP because of not having received an ARP from the CE. So it typically triggers an ARP probe. Now the ARP probe reply might go to the other PE, and that ARP entry has to be synced over to this PE, and the route type 2 has to be re-originated to achieve IP and MAC ECMP.
Conclusion, please.
Okay, so basically, I'll just conclude with this particular use case, right? Like so, as opposed to that, basically with LSOE, it's essentially once the host moves, the LSOE session is established to the new PE, and the route type 2 is advertised, and the network essentially converges. So it's like significant simplicity. So I'll skip the overlay, ND learning.
Yeah, just explain your next step.
Okay. All right. So
30 seconds.
Conclusion. Okay. So the conclusion being basically, what it's essentially trying to achieve is a deterministic convergence behavior across all sort of link failures, host mobility, and boot up scenarios. A learning procedure that is fully decoupled from any non-deterministic CE behavior with respect to data traffic coming from CE and so forth, and also address prefix learning for scenarios where there isn't a dynamic routing protocol running between the PE and CE. All right.
Thank you.
Okay. Thank you.
Satya?
Hi, I'm Satya from Cisco Systems, and my talk today is on the weighted HRW and its applications. So at the very basic level, right, we have a bunch of servers and some objects, and we need to devise mapping of the objects to the servers that will ensure like uniform load balancing. And also very importantly is like it should satisfy some minimal disruptions. When, like for example, a server goes down or a new one comes up, you want the reassignment to be as minimal as possible. That's the basic idea. And here, as I've shown, there are like servers at the top, S1, S2, S3, and there are some objects which I've put some number, like that's the key. So it's easy to see that the modulo n assignments are very unfair. Like if something goes down, server goes down, then the mod operator over S will result in all kinds of reassignment. So this is standard stuff. So what we did some time back is we used this highest random weight concept. We get a hash out of the server ID and the object ID, and that's some concatenation in some form, and we compute the hash. Whichever value comes out to be maximum, we assign the object to that particular server. So for here, you can see that 597, that's the object ID, object key with 597 is mapped to S1, and similarly for 318 and 233. Okay, so all this is standard, and we have used it in the DF election framework. We have used it in a couple of other EVPN drafts, like multicast. And then, but the key thing is, the talk today is like, what happens when there are weights? Like the servers are not of the same weight. And in this talk, we'll cover what is the application. So one approach is we can take the weighted score. We take the load fraction, which is the weight over we take the normalized weight, basically, the weight over the sum total of all the weights, and multiply the hash with that. And whichever comes out to be highest, we can again map that object to that particular server, right? But the key thing is, does it obey this minimal disruption properties of the HRW? So I've just cooked up an example here, the same thing as before with object key ID 233. And we have some weights, like server 1 is associated with a weight of 50, server 2 with 15, server 3 is 20, and server 4 is like 15. We take the normalized weight, and those are like 0.5, 0.15, 0.2, and 0.15, as you can see. And then we just, these things we will just multiply together, and then whichever comes out to be highest, we'll put 233 there, right? And so now let's say that the server S2, that weight changed from 15 to 25. So the normalized weight for everybody changes. And again, to do this computation, you should be able to see that we have to do these computations all over again for all objects, for all servers. So that's an order servers times the number of objects. Okay. So it does not satisfy really this HRW desirable properties, because you pretty much computed the whole thing again. So recently, about like 4 or 5 years back, there was a.
You have just 1 minute.
Okay, sorry. I'll try to be brief. Okay. So there is a new way to, like, there's another different way to compute the score function. So what they do is they take the weight and take the normalized hash value as before. And the normalized means you take this computation and take over this Hmax. Hmax is actually one more than the range of the hash function. And doing this will enable, like, if something changes, you only need to do that for that server. So I think one slide may be missing here. But anyway, I'll come to the gist of this. So using this method, we can come back to our the unequal load balancing problem that this advanced to the working group sometime back, top one. And these are the DMZ links, these are the PEs, these are the VLANs. And you can see that this whole problem that we did there, we'd use some empirical methods, and that kind of like set us thinking that this is not probably the right way. And then we thought over this. And then we find this, whatever has been done prior and what I just showed, we can just apply this here and it will automatically solve this. So there are some couple of other applications. That's why the name of the draft.
You have to conclude now.
Okay, so the conclusion is it's a new efficient way to compute the HRW for the unequal costs. I think that would summarize it.
Thank you. Thanks. Go have your next one.
Thank you. My name is Gaurav Davra. I'm with LinkedIn. Purpose of this talk is to cover the BGP-based overlay services. This draft has been presented before in IDR a couple of times. It was focused on BGP. It was and has been now moved to Bess. So there were 6 revisions which were there. So we presented in 98, IETF 98, the L3 VPN over SRv6. We presented the eVPN over SRv6 also there, including the global AFIs in IDR 101. We have this document has matured, and also the service SRv6 ecosystem has matured quite significantly. We have multiple deployments. Some of the customers are here. In fact, for our own use case as an operator, we have use cases for this. We also have relevant documents like network programming for SRv6, which are already in working group adoption calls. And also the deployments are there, which has been announced by a few vendors for SRv6 VPN v4. And there is work already going on for VPN v6. All right, so this is a minor update to the document. We took a lot of feedback which was there on the thread and also from the implementation. I have a slide which covers all the implementation across multiple vendors. So we modified the SID TLV, I'll cover that. We also included the SRv6 data sub TLV for some optional for the future proofing. And besides that, there has not been any major updates into the document. I'll skip this. We covered this briefly in IDR, but basically the whole idea is to create the BGP free core over the v6 data plane. And we're creating an SRv6 SID service SID for the VPNs and global AFIs. That's a service TLV. So essentially now you have a TLV type basically for L3 services TLV or the L2 service TLV. TLV length of 16-bit and some reserve bits for future. Then the SID information TLV is the core of it, which basically carries the SID information So you can have L3 SIDs for enabling the L3 services like NDX4, DX6, DT6, and these are all defined in the that Spring network programming document. So there's goes into a lot more details there. The L2 SIDs are also designed. We also have some arguments, which is I'll cover in the next slide what that means. And those provide all the L2 services with segment routing v6. And as I mentioned, there is a data subsub TLV, which is optional properties for the SRv6 SID for the to be able to encode some more information. All right, so what does a SID look like? So service SID actually has three functions, three properties. There is a locator, which actually tells you, how to route to that particular location, a function, which actually is a property of once you reach there, what do you have to do, and an optional argument, which tells you if you have to do something else, and it's a function of that particular node. It's just for the purpose of demonstration, it's showing that locator is bigger than function, but there is no such thing. A locator can be very, very small, and a function takes most of the part. So it's purely flexible. For the eVPN services, the base functionality for 7432 is not changing. Also, we are just using this new service SID to attach the information for both L2 and L3 with eVPN LLIs. As just a simple example for route type 5. So as you can see, the base route type 5 has not changed. The only thing is we are putting an implicit null label. Along with that, we are putting the SRv6 info sub TLV, which has, if you're trying to do a DT6 in that route type 5, which is basically doing a global lookup, or DX6 or DX4. So these are all defined in the network programming document. All right. Similarly, since the service SID is kept separate, TLV, it doesn't actually, it also enables for to be used for other AFIs. So in this case, the IPv4, IPv6 base behavior does not change. The only thing is the IPv6 next hop is used, and this is the whole idea is to achieve the BGP free core. And the same TLVs which I was showing earlier, you can use it for the global AFIs. So you have NDX6, NDX4, or DT6, which is basically saying look up into a V6 table, or DT4, which is saying look up into a V4 table. All right, implementation status. This was kind of, you can see, the overall segment routing V6 has matured quite a bit. So we have implementations on two vendors. So Cisco supports it on their iOS XE and iOS XR operating system, and it's across multiple platforms. So you have it on ASR1K, ASR 9000, and NCS 5500. On Huawei side, it's implemented on multiple hardwares, as you can see, and then on the operating system VRP v8. Barefoot also has implementation. We also have added the segment routing v6 support and this draft support into the kernel, and the FDIO also supports this document. Since it has been presented a few times in IDR, we are seeking the, I think the document has matured quite a bit, and there is already the implementations for this document in the production network. So we're seeking the working group production. Also, we are open to any suggestions and comments so we can address it before the adoption call.
Yeah, because this is the first time that you are presenting in Bess, so I hope that you have socialized correctly the document.
We have socialized and we have addressed a lot of comments which have been come.
Adrian?
Adrian Farrell, thank you for this and bringing it here, and thank you for the IANA section, which has cleared up the previously used code point quite nicely. I just want to check, implementation is really, really good. You've talked about deployment to production networks. What happens if this is adopted and the working group makes substantial changes to the protocol?
We're trying to, so the way the TLVs are defined, they're pretty backward compatible. We'll see how the adoption call goes and what comments come through. But since it has been socialized with multiple people across multiple vendors, we are not hoping for a major change in the document.
So
but comments are
I'm
welcome.
not talking about at adoption. I'm talking about during normal working group process as people start to review it and discuss it and change. Does that cause a problem for deployed implementations?
Well, as long as it doesn't cause us some major backward compatibility issue, we should be able to handle it in the BGP itself.
Yeah.
But we'll see how.
That was exactly the. So long as it doesn't cause is the problem. If it does cause backward compatibility issues, are the authors of this document willing to let the working group make those changes?
They will have no choice.
Well, I understand that, and that I'm sort of asking the authors. So, when you ask for adoption, you are saying that you are happy with that happening.
Jorge Rabadan, Nokia. Well, thanks for bringing this draft to this working group. But, I know that the draft has been around for 2 years, but this is the first time that it's presented here. So I don't think it's ready for working group adoption. And it requires some discussion in this working group. And in particular, in the last meeting, some of us gave some comments about the use of the draft for EVPN address family and the fact that it was actually breaking some stuff that we usually do in EVPN, like it's breaking the packing of EVPN routes, or it's also breaking things like the BGP encapsulation attribute that we usually send with the EVPN routes. So there are still a lot of things that require some discussion, especially for the brownfield deployments. So that's my comment.
Last comment, really fast.
Satoru Matsushima, SoftBank. We are the operator who are deploying this feature for the LS VPN on top of the SRv6 network. Successfully, we are deploying that feature. I think this BGP extension follow the segment routing manner. I don't think it's affect the normal procedure of the layers VPN signaling using BGP. If the working group see the possibility to change the substantially change this document, I think that means that it changes the whole segment routing manner with the BGP procedure, because already we have segment routing extension in BGP. This draft does adding one TLB and sub TLB in addition on the prefix seed. What the significant change will be happening? So please make sure what the exact change will be seen in the future in our network in this working group. So that's mentioned the uncertain possibility to mention that uncertain discussion down the road in this working. It's kind of just a threaten for the deployment in the production. That's a really counterproductive discussion. I don't think that discussion will make sense. So I support the adoption of this document.
Yeah, but we need also to let time to have discussion happening anyway.
Of course.
It's a matter of consensus.
I don't say that the discussion doesn't need it in this working group. Of course, this working group need discuss on this document, but so just talking about the uncertain possibility on this document is kind of the threat to the real deployment.
And also, this has been socialized with everybody. So it's not like first time. We have 6 revisions of this document.
Yeah. Who has read the document? Okay, thank you.
Thank you.
When?
Hi, I'm Wen from Juniper Networks. So today I'm gonna talk about this draft extended and optimized ingress replication for EVPN. So some background information. We have optimized ingress replication for EVPN draft, which is also known as assistant replication. It is IETF Bess EVPN draft. So the optimized ingress replication, it is a way to using overlay EVPN technology to deliver broadcast multicast traffic in a more efficient ways. So taking an example, you have see a diagram here, and if we have a low-end leaf node, while it receive a copy of multicast traffic, so in order to do deliver to east-west traffic to the rest of the nodes, it has to do ingress replication in the EVPN overlay. So this consumes the bandwidth, uplink bandwidth in the core. So the assistant replication provide optimized scheme. So the leaf only deliver one copy of the multicast traffic, and in the spine as the replicator will do assistant replication to replicate to the rest of the nodes. So this way, you see the advantage of saving bandwidth in the core and uplink bandwidth, and also alleviate the burden of the leaf node to do the ingress replication. So next, to support AR leaf multi-homing, for assistant replication, it requires AR leaf to using the local bias split horizon scheme. And because of that, the replicator has to retain the source IP address of its ingress AR leaf when they do the assisted replication. So the spine in this example has to remember the source IP address IP1 of the leaf when it does the assisted replication to the rest of the NV nodes. So this brings some challenge to the implementation. First of all, not the hardware can support these features. And secondly, there's an implementation complexity in order to do this. So the extended optimized ingress replication draft specify a solution to simplify AR multi-home support. And also, you know, it's sometimes the use case, some use case using MPS over X encapsulation, it may be desirable to using ESI label based split horizon rules. So the extended optimized ingress replication draft will support both split horizon method. On top of that, it simplified the AR replicator procedure. Okay, so this is a highlight. What's the extended procedure for AR replicator? AR replicator is no longer required to do the assistant replication for its AR leaf. So this way, it does not need to retain the source IP address or dealing with the ESI label of AR leaf in case ESI label-based split horizon rule is used. So the AR replicator support this draft will call extended multi-homing AR replicator is signaled to the other AR capable nodes. It is following this extended procedure through the control plane by attached EVPN multicast flag extended community. There will be a new bit set. When this bit is set, it means AR replicator is perform this procedure, extended procedure. On the AR leaf, so first of all, it will detect the AR replicator is doing the extended optimized ingress replication procedures through this community. And the behavior to the AR leaf is that it still send a copy of one copy of the traffic to its AR replicator. There's no change on that front. But AR leaf, in addition, AR leaf will do the normal assistant replication, normal ingress replication to send the multicast or bomb traffic to its multi-home peer. So this way, conclusion and the next steps. So as you can see, this extended optimized ingress replication procedure simplified the way how to support the procedure in the AR leaf. It allows the both split horizon methods to be used for multi-homing on the AR leaf, and it can also help overcome the hardware limitation for the AR replications. So as a result, so it still inherit the basic benefit of a system replication, like save bandwidth, core-link bandwidth, uplink bandwidth, and alleviate the burden of a low-end the leaf node. So we seek comment from the work group. Timing-wise, good. Okay, thank you.
We are globally out of time, but
okay,
so you have to go fast.
Okay, within 5 minutes. So I'm going to talk about a procedure for proxy MAC plus IP advertisement in EVPN. This is an enhancement built based on IFC 7432. So this is the scenario in the CE is a multi-home to a set of redundant EVPN PEs. So in active mode, normally depend on data plan learning mechanism. Only a subset of PE or one of the PE will learn the MAC IP host binding through R.ND. In this example, only PE1 learned this MAC plus IP binding, and through BGP control plan, the rest of PE learned this binding through BGP, right? So what happened now if the PE1 suffered a failure or the link between the P and the CE goes down, the whole trace of this MAC plus IP is gone because the type 2 PE1 will withdraw the type 2 routes, right? So there will be a gap before the PE relearn this MAC plus IP through other PE in the network, right? So this causes unnecessary network churn. So the solution to that is when PE1 receive this data plan learn the MAC plus IP through the control plan. If other PE only learn this MAC plus IP through the control plan, not the data plan, it will also advertise the same MAC plus IP through the type 2 route, but with the proxy indication. The proxy indication is done through the R.ND extended community. We allocated a new bit to specify when that bit is set. This is the proxy. And so remote PE, what happened to the remote PE behavior? There's no change. Remote PEs, there is no change in the procedure. Remote PE, not on this multi-home Ethernet segment, just behave as is today. So now when the node or link failure goes away, and if a data plan learned MAC plus IP is withdrawn, basically they don't have a proxy bit set. That means data plan learned MAC plus IP type 2 routes. Then those PE has proxy type 2 routes will start a timer. If within this timer it relearn this type 2 routes without proxy bit set, or it learned locally by itself, then it cancels timer, right? Otherwise, when timer expire, those PE, which advertise the proxy type 2 MAC plus IP routes, will withdraw the routes. So as you can see, this procedure, a simple procedure, covers the gap between link node failure and other PE relearn the MAC plus IP, and it's avoid unnecessary network churn. So next step, working group comments seeking. Ari, I know you have questions.
Yes, Ali Sajuasi Cisco. So we have the same situation for pure L2. How do we handle it currently for the pure L2?
Pure L2, you know, without EVPN?
MAC. No, just MAC. When, let's say, the MAC gets hashed to one of the multi-homing PEs, how do we handle that other PEs receive it and then the remote PEs do the proper load balancing? We do that, let me, answer my own question. We do that via the aliasing, okay? And this is basically an alternative method for aliasing for IP plus MAC. Question is, why not use aliasing for IP plus MAC? And for that, I introduced a draft 2 years ago regarding how to do it.
So, okay, I also have this question when I first working on this. You know, aliasing function on the way also achieve the load balancing. If you withdraw a little later, start a timer, same scheme, right? So the reason I see the advantage for using the proxy is that it's the whole EVPN network. So we have a different implementation from different vendor. You do not know what is the timer, whether this product has a timer, whether the other product does not have a timer, because aliasing features will also help overcome the network churn if the timer is introduced on the multi-home PE and the remote PE. So they need to work cooperatively. But when you have a different vendor's product, a different version, you do not know whether they all have the same scheme. So with the proxy bit, the idea is that remote PE, is ignorant about whether this type 2 route is learned from data plan or learned from control plan. So when the PE who advertised this routes through the data plan withdraw, the rest of PE still advertise through the proxy. So remote PE will still keep it. So that's one other advantage I see.
I don't see it.
Could you continue the discussion offline? I'm really
I
sorry.
can, yeah,
Sure.
discuss with you offline on this.
Sure. Quickly, in that draft, I go through the pros and cons of these different approaches. The problem with this is you have too many advertisement, and you're not capturing the issues and the cons for this approach.
It is,
I'm sorry, but please discuss offline. We are out of time, sorry.
Thank you.
Jorge?
Thank you. Okay, so this is a very simple and straightforward draft. So split horizon filtering is basically what we use in EVPN to avoid PEs from looping the traffic back to the CE in all active multi-homing. And there are two types of split horizon filtering. So one is the ESI-based split horizon, and the other one is what we refer to as local bias. So when you're dealing with MPLS tunnels, and you can use this ESI labeled split horizon, that's what you have on the left-hand side of this slide. So basically, CE2 sends bump traffic to PE1. PE1 it's going to send the bump traffic to PE2 and pushes the ESI label. And on PE2, because of that, we know that is coming from the Ethernet segment, and we will not send the traffic to the local same Ethernet segment. So when you're dealing with other tunnels, like VXLAN, for instance, or MVGRE, you don't have any ESI label. There are no labels whatsoever. So you rely on the tunnel source IP in order to do the filtering. And that requires some changes. And the changes are basically that the ingress P needs to forward locally to all the local Ethernet segments. So anyway, so both mechanisms have pros and cons. Basically, you have them reflected on the slide. But the bottom line is that some tunnels, they only support one of the mechanisms, but there are some other tunnels that they support potentially both. For instance, MPLS over GRE, MPLS over UDP, or Geneve. Those are tunnels that they can potentially support both types. So this draft is actually proposing a way to signal what split horizon type we want for a given PE. And it's basically taking 2 bits out of the out of the ESI label extended community to signal whether we want to use a local bias or we want to do ESI-based label filtering. And So in the draft, you can find all the rules and what to do in case of the MVE supports multiple encapsulations. And basically at this point in time, what we want is some feedback from the working group about this draft. So this is draft number 1. And draft number 2 is also pretty straightforward. And it's actually generalizing the use of something that we call a composite tunnel. A composite tunnel is introduced in RFC 8317, which is EVPN E3. And it's basically the ability for a P to advertise an IMET route, inclusive multicast route, with a special PTA, special PMC tunnel attribute. And in that PTA, the P is actually indicating that it wants to use a point-to-multipoint tunnel to transmit traffic, but it can actually use ingress application to receive traffic. So that's why it's a composite tunnel. So in RFC 8317, this composite PTA is only defined, first of all, for EVPN E3. And secondly, it's very, scope is very narrow in the sense that basically a composite PTA means we use always P2MP to transmit and ingress application to receive. So we want to generalize the concept and we want to make it available also for MVPN, also for multipoint to multipoint tunnels, also for assisted replication. And we also want to generalize the concept so that when we advertise a composite tunnel, we may also want to transmit on ingress application and not only on P2MP. So, and we do this basically because we have some use cases where this is important. So the first use case is this. So we want to introduce beer in an EVPN network where not all the Ps support beer in the data plane. So in order to do that, so basically what we do is we advertise a composite tunnel from all the Ps, even those that do not support beer in the data path. And in this composite PTA, for instance, we advertise the beer tunnel information along with an ingress application label. So with that, basically what we can do using the EVPN beer draft along with the beer PHP draft, we can have, all the Ps that do not support beer in the data plane, they can actually use ingress application to send bump traffic. We have a similar use case, which is basically is similar to the previous one, but the leaf P routers, they send a single copy of the bump packets. And we do that because we combine the whole thing with assisted replication. And again, in this, we are modifying the rules that we have in assisted replication draft in the sense that the leaves, now they need to advertise a composite tunnel with the ingress application label and also with the beer tunnel information. So again, it's very quickly, we want to request some feedback. We believe it's a very interesting draft and allows you to introduce, for instance, beer in networks what you have Ps that do not support beer in the data path.
Michael? You have 5 minutes.
Okay.
No more.
Total?
For your presentation, 5 minutes.
Okay, and I probably won't even take that because we like Sandy and we'll make sure that she gets enough time. So in a nutshell, what we're trying to do is to make the EVPN designated forwarder election a little bit more granular to include multicast bandwidth or bandwidth as well as state. So you are able to go beyond what we currently have with source and group, but also to extend it a little bit. And we do that through using an extended community attribute using new types, both a type for bandwidth and a type for state. And we leverage the extended community from IDR, link bandwidth extended community, to be able to share that amongst PEs. So that's kind of it in a nutshell. Those of you that are familiar with this problem space know that there has been, with EVPN designated forwarder election, an increased granularity with selecting that designated forwarder. It began with 7432, and there's been some drafts that many of you have worked on. I have not participated in that, so I'm not sure if you've had conversations with regards to making it even more granular with regards to link bandwidth. But that's what we're proposing to do here. And there could be a variety of ways to do that. And we just have the one suggestion. Yeah.
So I can wait till end of the presentation. Basically, I just want to mention there was a draft that Satya presented earlier. It is for the exact same problem space, and that is and it is called weighted HRW, such that when you have different link bandwidth, how you do the DF election at the different level of granularity with the minimum disruption. And the application for it is, one of the applications is for multicast.
Okay.
Different bandwidth community is non-transitive, so it's not going to work in eBGP scenarios.
Okay. All right, so I probably don't need to go over the justification of it, but it just suffices to say with the existing DF election mechanisms, there could be links that are overloaded and the bandwidth is not shared properly amongst the different links. So that's what the problem that we're trying to solve. Our solution, I've kind of already described it. And again, we're using the IDR link bandwidth to that extended community to be reused to transfer among the PEs. I don't have time to go through these, but just basically show how you can how that we can make this work. And next step is we've done already what we want to do. Just make sure we're working on this. If you do have interest, please talk to us. If you think it's a silly idea, then we'll drop it. But if you think it's a good idea, we'll keep going.
So just quick note. May I ask for you to review the other draft?
Sure. Yep.
Thanks.
Yeah.
Last speaker, Sandy.
Good afternoon. Thank you. Oh, good. Good afternoon. I'm Sunny Zhang from ZTE. This presentation is for BFD usage for EVPN ES failover use case. We have co-author Yubao and Greg. Let's see the problem statement. We know that this is a traditional network in EVPN. CE is multi-home to PE1 and PE2. And we know that if the link between PE1 and CE fails, until PE2 is elected as DF, the BAM packet will all be discarded because the procedure includes the BGP advertisement and the PE2 runs the election function. So it may take time. So the BAM flows will be discarded until PE2 is elected as DF. So in order to decrease the packet discarding from PE2, we use the mechanism defined in FC 5884 and the subtlety defined in Gen-based EVPN LSP to improve the situation. So we know that the BDF in this example it's P2 generates LSP ping echo request message to bootstrap a BFD station between BDF and DF, like the P2 to P1. The EVPN Ethernet auto-discovery subtlety defined in Gen-based EVPN LSP ping is carried in this message, and also a local BFD discriminator is carried in the message. When DF in this example is P1 responds with the BFD control packet with your discriminator set to the received discriminator from P2. The BFD session can be built. And we know that P1 will send a periodic BFD control packet to P2. So P2 will know that if the situation between P1 and CE is normal. When P2 finds that the link between P1 and the CE link fails, the P1 will send the BFD control packet with the state set to admin down to P2. So B2 can detect the failure. And if this packet is lost or something missed, P2 also can find the situation from the detection timer expiration. So BDF can become DF immediately and forward the BAM follows to PC. Yeah, it's simple.
Alice, I'm going to be quick since we are running out of time. So the whole premise for this is basically to be able to do fast detection, and the current approach of withdrawing the route via the BGP, we think it might be taking too long. But a couple of issues I'd like you to consider. One is, what if there is a congestion between PE1 and PE2 and the messages gets lost? And in that case, the backup DF thinks that it should be a DF, and now we got two DF and we have duplication. That's one. And the second thing is, what happens when I have unequal bandwidth, and in that case the link fails and the BDF moves, and are you going to try to set up a new session for the BFD? And this kind of thing, I think it hasn't been touched upon, and it needs to be seriously considered.
Thank you. I'd like to say between P1 and P2, there's many ways to build the session, and the session can be through the LSP or IP packet. So this is the first, and we know that BDF maybe there are many BDFs in this situation, right? So one BDF is elected according to the same algorithm, DF election algorithm. We know that from the DF election framework, we can use many ways to elect the BDF. So we must use the same algorithm in the network to select the unique BDF.
Right. My point is, it can move,
Yes, they can move.
Steady,
Yeah. When it is moved, a new BDF will be elected. So a new BFD session should be built. Yeah, we will add more details in our draft. Yeah, thank you.
Okay, so the session is over. Thank you for your attendance, and see you in Montreal.
Thank you.
Blue sheets, if you have the blue sheets, could you bring them to the front, please?
That's fine. Wow. Somewhere behind. That's two packages. Yeah, next time we need to see if there is a possibility to have 3 hours. Let's take 3 hours. But sometimes it's even not possible to have 3 hours. So yeah. But you may be alone.